Hi, everyone. Hopefully, mic's working. Yay! Lots of pictures from the front row. That's my colleagues and friends. So, woo, excellent. Basically, right? Everyone's been asking me, is it going to be live? I'm like, I hope not, and I'm not giving you URL if it is. So my name is Dimitri. I'm on GitHub and Launchpad and lots of places. I go by Xnox. That's my IRC nickname from school, because that's how young or old I was when I was using IRC at school. And I do Linux distributions for basically all of my software development career, right? So I'm a Debian developer, I'm a Ubuntu core developer, I help to bootstrap and start Intel Clear Linux from scratch, even though now it's dead and deprecated, but at the time it was very exciting to work on it. And lately, for the past year and a half, I've been at Chainguard, building Chainguard OS to ship lots of containers to lots of people. And progressively, with each operating system that I build, I am trying to do things better, right? Because I eventually hit limits of what's possible with deprecated stuff, existing users, past users, and I move on to the next thing to hopefully make it better, right? And I did lots of things, right? So I'm not predominantly OpenSSL developer, I'm not predominantly kernel developer, but I have done kernel development. I have done OpenSSL development. I've built installers for IBM Z and worked with all the accelerators that the previous talk talked about, and lots of other fun things on Intel side, and so on and so forth. But this is OpenSSL Conf. So to focus about OpenSSL and related technologies, I have upstream contributions to everything, right? I've contributed to OpenSSL, LibreSSL, BoringSSL, AWSLC, because most of them are the same code base, such that when I find bugs and interoperability issues, I don't fix it just for myself or my own customers. I go out there to fix it everywhere else, because if things don't work in one place, they don't work anywhere else, and unless we fix everything, nothing will ever work, right? And we have some very interesting OpenSSL forks. So like lots of people focus about like Boring Crypto is fast or AWSLC is fast, but nobody like mentions OpenSSL forks that are shipped in RHboot shim used by all Linux vendors for secure boot. Nobody's talking about OpenSSL fork inside EDK2, which cannot panic, cannot do at exit, cannot do forks, or cannot do DL open, and yet all of the technologies that are presented like at this conference, they rely on things that are impossible to do in firmware, hardware, in confidential compute. So for me, my interests are very spread across the board, and lots of stuff that OpenSSL tries to do may or may not work for everybody to upgrade to. And that leads to lots of issues, right? So specifically about OpenSSL, I did interesting things in terms of trying to backport hardware acceleration. And that's a never-ending story, because there are more and more platforms, more and more algorithms, and all hardware vendors tries to accelerate stuff for their own platform to get an edge over the other one. And then everybody wants to use it on Ubuntu, and they want to use it as fast and as soon as possible, right? And historically, OpenSSL upstream would not backport hardware acceleration to stable releases, even though it changes no public API, it doesn't change public ABI, and it generally makes the software run faster. So when forks came out, such as Boring Crypto, AWSLC, predominantly it was performance-based, because there were patches out there that could make your cryptography faster. And historically, OpenSSL wouldn't ship it, but Ubuntu would. And I would do lots of work to backport that stuff to actually make it faster on existing hardware, on existing releases for people to actually use. And I've tried to do fun things like upgrading OpenSSL in a stable Ubuntu long-term release, and I'll deep dive into that a little bit, because I thought it was gonna be easy. And we do things because we think they will be easy, even though they don't usually turn out that way, right? And stuff about like disabling TLS11, that was also interesting. So I have a blog post telling people how to do futuristic things. So for example, how to disable TLS10 on Ubuntu 18.04. And that still has lots of hits even today. It has like over 40,000 views. It's reshared very widely. And there is a sister mirror issue where in next release, we've disabled it by default, but people need to enable it back on. And there is a sister issue which says how to enable TLS10 in the next Ubuntu release. And the two of them continue to compete for traffic. They're still top 2 search results for TLS10 and Ubuntu, right? One of them is how to turn it on, and the other one is how to turn it off. And I'm like, it's 2025. We have TLS13. Why do people care? Anyway, they do. So lately, when I moved to Chainguard, I've tried to always ship latest upstream release, right? Such that I'm trying to ensure that is it actually possible to ship latest releases of OpenSSL for the whole open source ecosystem of projects and actually deploy it in production. So I'll deep dive into some of these topics and we'll see how we get there. But fundamentally, everybody wants the good stuff without the bad things. And I try to deliver that, but it seems to be impossible. So like, for example, OpenSSL has stable releases. They backport stable fixes, security fixes, performance fixes. But when you look at a distribution, such as Ubuntu at the time, they would freeze to a point release from upstream, and then they would only cherry pick individual patches and changes, simply due to historical perception and prejudice that upstream breaks stuff, and we cannot trust to take the full upstream point release. And that is true for many other distributors of OpenSSL, right? They treat minor point releases as brand new software versions, which are not to be trusted, right? And that leads to duplication of work, right? So hardware vendor implement acceleration, they get it into upstream OpenSSL release, they even get it backported to a stable OpenSSL point release, and then they still need to go to all of the major distribution vendors to say, oh, can you please go and cherry pick it again, test it again on the hardware that we gave you access, and actually give it into the hands of the users. And it seems to me that all of the stable updates policies are incompatible with each other, but I hope that somebody can actually try to make it better, right? If a hardware vendor comes to you, I have microcode, I have assembly, and it works, and it's deployed across the whole hardware that people in public cloud are using everywhere, we should just backport and ship it across all stable releases as far back as we can. Some people shake heads, some people say it's impossible, but maybe that's the future. Maybe it's never possible to do so, and we will always be stuck in this churn where lots of people need to duplicate the same work over the time. If they manage to land it, great. If they can't, and so on and so forth. Because I agree, for someone, it's a very good thing. For another person, it's a bad thing. And then everybody wants to choose what the good things they want, right? So it's hard. And for Ubuntu in particular, where am I? Yes, for Ubuntu in particular, we try to maintain a stable ABI. And maintaining a stable ABI is very hard when your release cycles are 12 years long. And for example, some security fixes would remove ABI from the libcrypto or libSSL public APIs, which at runtime breaks all software, whichever referenced it at link time, because we have bind now, even if they're never going to use that API at runtime. And we've had this with Poodle, we've had it with previous Heartbleed attacks, and we will have it again where a security bug fix removes ABI or API. And at Ubuntu, our security team would always by hand backport those things. And it's very difficult, right? And it annoys people, right? Because lots of things happen. Okay. Not regular release schedules. I want OpenSSL to automatically tag releases every 2 weeks on Tuesday and continuously do that all the time. Like, if you look at the kernel development, they have a new tag every 2 or 3 weeks, and they just move on with life. And people will pick and choose what to run, right? Because historically, the release cycles were very long and unpredictable, which doesn't help with scheduling of anything downstream, and it doesn't help for users to schedule either. Recently, OpenSSL is trying to switch to more regular releases of 6 months, but OpenSSL codebase is relatively small, and yet it releases so infrequently compared to other projects which have much larger code bases and manage to release more often. Linux kernel is massively much bigger, yet it releases more often. There is a disconnect there. And in particular, for example, the 1.1.1 release of OpenSSL, which was a major version, which was ABI and API compatible. At least that was the promise. And it had exciting features like TLS 1.3, ED 25519, modern cryptographies, the way of the future that everybody wanted. The release schedules didn't align. So we had Ubuntu 18.04 released in April, and OpenSSL, it was very close, very late, slightly delayed, got released in September 2018. A few months' time, but it's a difference for the next 12 years, which is still affecting me and everybody else who's running like Node.js and Ubuntu 18.04 in production with common criteria certification, FIP certification, and so on, right? So it may seem old, but it's actually in production out there. And at the time when we did this release, I was like, this is gonna become important. There will be demand for this. We need to do something. So even before 18.04 shipped and Launchpad, we started to have community customers and asking for us to backport new OpenSSL, right? And then we were like, okay, fine. We'll wait for OpenSSL to release. We will test it. We will land it. In theory, it's API compatible, like forward compatible. We'll land it. No changes needed. We're going to be like easy peasy. So it was okay, right? So when you look at the heat map, 350, it was one of the highest issues affecting most amount of customers, people and everybody. And at the time when I had to land this, I had to upgrade a dozen or so packages to actually support the new OpenSSL 1.1.1. And the differences there was that, yes, ABI was compatible. API was compatible. At runtime, things would fail and not work at all unless you use the right initialization flags for the init calls. If you do or do not call certain APIs, connectivity would not work at all. And that was very lovely because lots of test suites at the time and integration test suites, they were not generating self-signed certs and they were not actually testing TLS connectivity, such that we only found out some of those issues after we landed the update, which sounds horrible, right? And some of the fixes were very annoying. It was remove explicit OpenSSL init calls, because if you use an implicit one, it had updated flags and it would have just worked. So some of those SRUs and updates that I had to do, they were patches of 12 lines code of removing code and removing API calls to make things work. And that was easy for me to do, but it was annoying that it had to be done, right? And I thought we were done, right? Everything was working. Node.js was declared as ABI incompatible. So as soon as we landed that, everybody was starting to complain that I'm using Ubuntu. If I use packages from Ubuntu, everything works. Node.js is compiled with new OpenSSL. Node.js extensions are compiled with new OpenSSL. Life is wonderful. People go and do npm install packages and compiled extensions for Node.js from the public repositories and third-party developers. And all of those things have already pinned to Ubuntu 18.04.0. They already pinned to OpenSSL 1.0 or 1.1.0, and they were literally incompatible at runtime. And we were like, okay, we cannot handle this for the next 12 years. We will downgrade Node.js to use a different OpenSSL, lower ABI, lower feature set, no TLS 1.3, but to make sure that everything is compatible with everyone out there in the world, right? And we're like, that's gonna be fine, okay? Finally, it's over, right? It wasn't. When you ship 2 versions of OpenSSL, they try to install files to the same file paths. They're trying to provide the same library at link time, and they're trying to use that. And then you have people who want to compile and node bindings for OpenSSL for their third-party SDK, and the Python bindings and the Ruby bindings, and each one of them needs a different version of OpenSSL because of the choices we made, the choices I made that I still regret and still bite me for another 8 years. And there is no solution to this, right? So for example, today I still suffer from this, but also it keeps repeating. OpenSSL 3.0 and 3.5, the dev headers are incompatible, they installed to the same path. I've packaged AWSLC, AWSLC FIPS. All of them install OpenSSL, OpenSSL.h headers. Boring crypto installs into the same path because it makes everything work. And when you have multiple software that wants to use different forks of libcrypto.so, it's virtually impossible to make it safe and make sure the right thing uses the right copy of libcrypto. So this is old, yet it's still unsolved, and we keep creating more forks of OpenSSL, trying to support them in parallel at the same time, making everything worse. What's the takeaway here? ABI changes are hard, right? And people are chasing new functionality. And third-party systems try to pin to ABIs to make things work universally. And breaking ABI is impossible, yet you need to make changes to make progress. And then you're stuck where I'm told to satisfy incompatible criteria for everybody. And then after I did all of this work for 1804, we had customers come to me and say, okay, this is amazing. Can you backport it to 1604 and 1404? You did 1 LTS, why don't you do 2 and 3? And they're like, here's a check for $1 million. And I'm like, no, why don't you upgrade? Because upgrading is free, and since you want to give me money, it means you can give money to your internal teams to address your technical debt to upgrade. And then salespeople, they were annoyed with me because that's their commission. And then all of the engineers from all of those customers teams, their eyes lit up, and it's like, yes, we use new stuff, and it's amazing. When your vendor tells you to upgrade, it's the best outcome for everybody, right? And often runtime behavior changes are easier to land. So as we can see with all of the provider framework that lots of talks this week were talking about, it makes life easier where your API and ABI is stable. You don't need to recompile your software. And yes, you're swapping out the whole cryptography stack behind those API calls. Behind that indirection, it helps everybody that at runtime you can swap RSA for a FIPS implementation of RSA or for a post-quantum algorithm or whatever, things work. And that does help, right? Because runtime behavior changes, people complain about performance differences, but they never complain that nothing works anymore or that their binary doesn't start or segfaults such that the thresholds are better, right? Okay. Lots of fun stuff. But with OpenSSL 3.0, the promise was that the ABI is stable and that you can compile against OpenSSL and then you can continue run with newer versions of OpenSSL. Well, that's not true and it's not true in the same sense like the glibc ABI is stable because, for example, irrespective of how you compile glibc, it will always expose the same public symbols with the same symbol versioning scheme, and it will always have old copies of the symbols with the old behavior such that the binaries compiled from 12 years ago, they still run correctly on the newly compiled glibc. That's not true with OpenSSL. Even if you take the same major version and if you go to multiple distributions on the same architecture, you will see that there is different public API exposed because depending on the compile time options, it will affect which public symbols are exposed. If a compiled choice, whether you enable engine support or disable engine support, changes the public symbols that are available out there, it makes your library incompatible with existing builds. And as we saw with Node.js, if there was a public API or a public API, somebody was using it, somebody was broken, and somebody will complain to you enough for you to revert it, right? So like today, we're talking about like trying to create the new OpenSSL 4, which will become like long-term release, and will finally remove deprecated APIs and APIs that were removed like years ago, right? But there are still applications out there that still have code that was contributed by OpenSSL people to load engines, to init all of the engines. And today you look at lots of software. If I disable engine support, lots of apps will break. And like Fedora is doing amazing work where they are keeping engine API in the library, but they're compiling it out of all of the software that they have, such that when they move on, all of the applications are not using engine APIs, such that when you finally remove them, hopefully nothing will happen. I'm carefully watching what they're doing there, because hopefully if they do it right, everyone else can copy their homework and life is wonderful, because I've had enough trouble as it is, right? So like I've attempted to turn off engine support in Debian, Ubuntu, and Chainguard, and I was like, this is too hard. I just turned it back on, and I'm like, just move on with my life. Because things like this are hard, right? And there are lots of fun things like obsolete algorithms, and it started to become a trend that lots of CRC functionality and lots of compression is just assumed to be available over OpenSSL. I am glad that like compression algorithms are finally like removed from libSSL, but back in the day, people were calling gzip via OpenSSL because it used to be available because you had to compress your TLS, and it was like, no, don't do that. But MD4 is still actively in use in Node.js land with Webpack, which is used to create a perfect hash table of key value pairs to look up and compress your JavaScript files. They have moved on to XXHash in Webpack 5, but JavaScript developers don't upgrade that quickly, such that even today I have requests in FIPS mode to add MD4. And I'm like, look at the calendar, and I'm like shocked and surprised, and then I look what it is, and it's like, okay, amazing. For people who are Node.js developers, upgrade to Webpack 5, or there is an excellent NPM package called Webpack MD5, which literally registers an MD5 implementation in JavaScript and replaces MD4 with it at runtime, and it's very popular. And it's very popular because clearly it's easier to do that than to move on from MD4, right? And we're talking about post-quantum cryptography. I'm talking about MD4. So this is the disparity between what distributions have to deal with and what upstream is working on, right? There is some more stuff here, like for example, config options often do not apply to libcrypto. So libcrypto deals with math and low-level cryptography. libSSL deals with TLS. If I run generate RSA key or generate RSA cert, I can generate a weak key which is smaller than 2K RSA, which will not be accepted by any web browser, it will not be accepted by any CA, and it will not be accepted by OpenSSL itself. So libSSL will reject it, libcrypto generated it. I keep saying that maybe you should stop supporting generating RSA keys that are smaller than 2K because they're long obsolete. And people, like in the PRs when I've tried to do it to OpenSSL, it was hilarious. The comment was, there are upstream test suites of third-party software that generate test keys that are small, and we want to keep them working. And I'm like, that's not production code. And test code should match production. Their test cases are broken if they're not using the same key sizes and expectations as they will experience in production. If your test cases relies on cryptography nobody uses, that's not testing. But that's my experience. It's not what the world out there is, right? So how can I solve all of this, right? So somebody says, okay, well, drop support for all old versions. Always try to ship latest OpenSSL. It must work everywhere. And if you use the latest APIs, you will never be incompatible because you have access to all of the APIs that are out there, in theory, right? And I'm trying to do that. So I've been doing that at Intel Clear Linux. I'm doing this now at Chainguard, and it's difficult in different ways. So for example, it requires extensive testing because the software that you're shipping has been unlikely to have been used by anybody else before you. So at Chainguard, when we deploy new OpenSSL, we spin up lots and lots of Kubernetes clusters, and we do end-to-end testing where we do Helm chart deploy of all containers, all of them built with latest OpenSSL. And then we do deploy workloads on those to verify that end-to-end everything works. And our principle there is if end-to-end everything works, it's likely that individual unit tests, individual integration tests of the whole software stack will also work. And it's much faster to find regressions, such that instead of trying to do micro benchmarks and micro test unit tests, we try to do the biggest end-to-end test that we can possibly have, right? And that helps us to speed up testing and landing changes. And even then, we find incompatibilities with the FIPS provider, incompatibilities over the internet with older providers or other software. We do experience regressions, and our solution to that is that we will patch forward and we will fix regressions and re-land the changes again, rather than trying to fight the fact that there is a regression or try not to upgrade. And it does take toll because it's spiky, and we're sort of getting there. And it doesn't help with dropping ABI changes, right? Because I've tried to disable engine support. I've tried to recompile everything. It was not possible to land atomically across the whole distribution, across all software projects with support. So I just kept it on because people continued to do pip install, UV pip install, npm install, stuff uses engine API, even though there are no engines in a Kubernetes cluster container, but they all init OpenSSL engines. And I'm like, excellent. Here's an example of what we did this week, right? So, or a week before. So we've landed 353 OpenSSL. It had a regression because it started to calculate the version string differently, and OpenSSH has an exact match on the version string of OpenSSL, and because of a bug fix to fix how that's calculated, it was crashing OpenSSH sessions for everybody at startup of the server and the client. We backed out. We've downgraded OpenSSL to unbreak everything straight away, such that all of our Kubernetes clusters go back to healthy. And then we backed out the version check in OpenSSH, which was not useful or not doing anything productive and should not have been there. And then we relanded 353. And then 2 days later, 354 gets released, which reverts back the bug fix to fix the version string because of the reports that OpenSSH no longer works. And for us, we were like, okay, that's good. That was like 2 days too late for us. So for us, we've managed to patch it and move on with life quicker than all of that propagated to us. And then 3.6 actually released at the same time as 3.5.4, but for major versions, we do a lot more integration testing, such that it took a few days, so like 5 business days for us to upgrade to 3.6.0. But when we do those upgrades, it goes to everything, right? And by everything, I mean that, yeah, that's what we did. By everything is that we have roughly 17,000 projects and containers and version streams of stuff that we deploy, and we fully automated together in FIPS and non-FIPS mode, together with all of the providers that we currently support, such as 3.1.2 provider, 3.4 provider, 3.6 provider, which we are on the verge of submitting, but we're not quite there yet. And Just to give you the scale of stuff that we have to test, this is roughly 3 years of stats, and they keep accumulating because big numbers look good for marketing, right? So you want to divide this by 3 to actually know the full scale of Chainguard of what we're doing. So we roughly have 100 million container builds a year, and we do full testing of every single build and every single update of those. And if you look on the previous slide, when the screenshot was taken, OpenSSL was deployed 5 hours ago, right? And across all of our container stack, it was already pre-tested. You see that roughly at the same time, we rebuilt for Python image all version streams of 3.5, 3.10, 3.11, 3.12, 3.13, because we give a choice of customers to use any stable version release of any upstream project. And we upgrade dependencies. So it is obvious that when 3.9 Python was released, it didn't even know about OpenSSL 3 or 3.1 or 3.2 or 3.5 or 3.6, but now we're running it with 3.6 after completing our integration test suites. And this achievement, I think, is great for me because I believe I'm getting users useful, stable software. Yet at the same time, I'm managing to upgrade all of the dependencies and give them access to latest APIs, latest ABIs, latest versions of everything they can possibly want or need, such that my requests for newer versions of stuff is virtually 0 because it's always available to them. And they don't have to upgrade from Python 3.9 to get access to latest OpenSSL. They don't have to choose to run 3.11 because that's what Ubuntu LTS shipped or rel whatever shipped, right? Such that it's always available to them. Is there a silver lining? I think so. We should help upstream projects to not use deprecated OpenSSL APIs. OpenSSL developers know best how to use OpenSSL the best way. We should contribute to Python to move off HMAC obsolete APIs. We should help .NET move off HMAC obsolete APIs, and so on and so forth, right? And same is true for removing engine support. We should contribute those patches. They shouldn't be just in source fedoraproject.org as a patch file. They should be all upstream. And today, if I turn off TLS11, if I turn off all deprecated APIs, Python, Node.js, of all stable supported versions of upstream will all fail to build from source, and they will fail at runtime. That's the reality. And if you want to rip out all of the deprecated APIs out of OpenSSL, we need to fix all of the upstream projects of all of their stable versions to be compatible with the future. There is no way around this. This is work that needs to happen. Conflict-free patches. I despise that sometimes patches change news entries and changelog entries. We have gitlog for that. You can generate it from gitlog. Python projects use snippet files where they can split out changelogs into a separate file which is conflict-free on cherry picks. That would help everybody for maintaining their stuff. If they have a regression, there is a bug fix in a future version, they want to cherry pick the bug fix alone, and it ideally should be conflict-free. That will save universally a lot of engineering time. And this is something that you have to do on commit to prevent future waste of hours of developer time. Help security scanners tag things. Like I said at the very start, I wish OpenSSL would release every 2 weeks on a Tuesday and create a new tag. The more tags, the more releases you have, the more milestones there are, the easier it is to do step updates and also to make sure that people can keep up quicker and easier. And we shouldn't have 6 months gaps between major releases. That's too long. And do you have any questions? There are 2 banned questions.
Do you guys do your own FIPS validations, or do you rely on SSLs?
So let me go back to FIPS validation. So we ship about 17 FIPS cryptographic modules of different state and status. So we have some that are rebrands. There are some that we use from other vendors directly. And there are those that we've submitted ourselves and they are in progress. There are some that are in review. And there are those that are implementation under test and not submitted. So we have the full spectrum. So for example, the 3.4 module that we've submitted in spring, it is fully 2030 ready for all algorithmic transitions. It has no deprecated algorithms, and it has no as little dynamic indicators as possible. The 3.6 that we're almost completing our functional testing and about to submit will be fully 2035 ready with post-quantum cryptography and all deprecated legacy usage also upgraded and removed.
You're skipping 3.5.
It's too old. Like, have you not seen that I'm on 3.6? 3.5 is dead to me.
It's too old, but it will be. Its support will end by 1 year and 1 month.
So yeah, I understand that, but like for my customers, they want Python 3.9, and they want it to work. And they don't care which OpenSSL it uses.
I have a question.
Yeah.
Why do you need tags? You can
Tags.
just grab like latest nightly. If you have like our nightly CA passed, you can just use it. But it like a release wouldn't be better.
So the release is better for security scanners, because when you publish a CVE, you say which versions and which tags a CVE was fixed. When you point security scanners at Chainguard containers, it literally says 0 CVEs because all of the software is using upstream versions with upstream tags, and all of the advisories automatically match with no manual human work of trying to create advisories to specify that FC42 build 0 or build 2 fixes a CVE. And that's where the advantage of upstream tags and version numbers matching the advisories and matching NVD feeds and CVE.org feeds, which are then used by a whole bunch of security scanners. So the tags and version numbers matter to be SemVer compatible, to be always incremented and match the advisories. So when 3.5.2 had a CVE and OpenSSL chose not to tag a stable branch, the security scanners chose to say it's unfixed CVE, all versions are affected. Or they chose to say that the next version has to fix it such that they made up a future version where they said, oh, 3.5.3 will fix it, but such tag and upstream version doesn't exist. And then a whole bunch of automation just fails on its face.
Okay, would you be happier if we will just tag any nightly like builds that will pass us nightly CI?
Yeah, but it needs to match the CV advisories you publish.
Okay.
Right? So, and like you say, you care about 3.5. What if I'm going to tell you to care about 500 builds or 52 builds a year? That's a bit too much. So there needs to be a balance there.
There needs to be a balance. One option would be basically to sit on the low CVEs until the release is done. Yeah, and we should do more frequent stable releases. I'm definitely not against that. What I am against that doing it every 2 weeks, because we could not be doing real releases.
There is a proposal that I'm brewing is like, for example, if stable branch is not ready to release, fork the very last tag that was tagged, apply security fix there with no changelog, no news, create a micro tag called 352.1, and then merge that into the stable branch, because that gives people a tag and automatic generated tarball that they can use for build. It gives a version number which all security scanners and feeds can use. And then when you look at your stable branch, the snapshot build, the one before the merge of the security fix will say that it's a previous tag plus 36 patches. And the one after the security merge will say security fix is fixed and you have a new version number plus 3 patches or +4 patches, because in your mainline development, you need to segregate this fence. Up to this point, it's vulnerable. Up to this point, it's not vulnerable. And that proposal will go to communities after the conference because I'm busy, and it didn't go before because there was embargo, because there was a CV that was about to be published, and I don't break embargoes.
Okay, so thank you for your presentation. This is exactly something that we are looking as a feedback for the BackTech Corporation distribution community. So I'd like to invite you and everyone who's interested in distributions. We should meet in just 1 minute.
In 2 minutes, yeah.
2 minutes in the Belvedere 5, the laptop room, so we can talk, how we can, provide feedback from distributions to OpenSSL community.
Okay. Well, thank you very much for coming.